Problem 1.15. It says the 100 Newton force is required to operate the foot pedal. Determine the force in the connecting link and the force exerted by the lever on the bearing. Neglect the weight of the lever. So this is the connecting link that we need to find the force at. So for this purpose we will try to draw the free body diagram here. So if you look at this point O, it looks like it's a pin joint, so this will bring us one horizontal support reaction, call this Rx, one vertical support reaction, call this Ry. Now to solve for these reaction and the connecting rod force, we can do the static force balance, and for that purpose we will do the summation of forces equals to 0 and summation of moments equals to 0. For the force balance, I'll first look at the x forces. In x direction we have Rx, and we have this F force that can be divided into two components. This one will be F cos 20 and this one will be F sin 20. So in the x direction we are going to have minus F sin 20 because it's going backwards equals to 0. Similarly in the y direction we have this Ry force, this 100 Newton force, and the y component of F. So Ry is going up, that's why positive, then minus F cos 20 degrees minus 100 equals to 0. So we got two equations, but we have three unknowns. So let's look at the moment equation. In this case, finding moment about point A would be better because both Rx and Ry pass through that point and they will not appear in the moment equation. So when I take moment about point O, this 100 Newton force here, it is sitting at a distance of 250 mm, and about point O, this will try to rotate this in the anti-clockwise direction. So 100 newtons times 250 mm. Since it is anti-clockwise, I'll put a negative sign there. Now for this force F, the issue is that this is an inclined force, so the moment arm for this force will be this right here, okay, and this length is not known, and I am assuming here that the angle between the connecting link and the pedal here is 90 degrees, okay. So now this length L, how do we find that? For that I'll draw a separate triangle here, and from there you can see that this horizontal distance is given as 150. This angle right here is 20 degrees. This length is L. So if you look at L cos 20 degrees, this should be equal to 150. So from this we can figure out L, which comes out to be 159.6 millimeters. Now once your L is known, I can find the moment about point O. So this force F, we try to take this system in the clockwise direction. So the moment will be positive moment, force is F, moment arm is L, equals to 0. So now from the moment equation, if I substitute the value of L there, I can find the force F, which is 100 times 250 divided by L, which is 159.6. The value of F comes out to be 156.6 newtons. Now I can take this value of F and substitute in equation number 1 and equation number 2 here. Equation number 1 will give me the value of Rx, and the value of Rx after substituting the F and sin 20 there comes out to be 53.6. From equation 2 we can find the value of Ry, which is 247.2 2 newtons, and F value, just to summarize everything, is 156.6 newton. So that's the final answer for this problem.